In this video, I'm going to start the process of learning postMessage bugs. This is a bug class I've wanted to get into for a while now. If you know who I am, you've been following the channel, you know I've been doing a lot of work on the client side, getting to know the JavaScript files a lot better, actually starting to extract, beautify, and take params and stuff from there. So I believe the next step would be learning postMessage bug hunting. So I have YesWeHack pulled up. I read this. I also watched this video here by AmrSec. And I did some ChatGPT stuff trying to learn more and create this slideshow. But first, if you don't know who I am, my name is Logan Sec. I've been a bug bounty hunter for the last 9 months now and releasing out my first valid bug on the Canadian government. However, I'm still in the progress of getting my first paid bug, and that's pretty much going to be the number one focus until I hit it. But first off, I just wanted to go through, because I still don't quite understand postMessage bugs, so I'm just going to go through learning it a little bit first. So what first I did was I watched this video by AmrSec. Very good video. I believe it's very underrated. There aren't very many videos on the topic of postMessage bugs in the first place. Like if you scroll down, you have critical thinking from postMessage exploits from 3 years ago. This a year ago. Maybe this is something I could watch. Why Hackers Love postMessage came out a month ago. Probably have to watch that. But there's genuinely just not very much out there when it comes to postMessage. So very first thing I did is I watched that video and then I read this. So let me just give you guys like a quick overview. So introduction to postMessage. So basically it's anything with the method window.message is used by application to allow cross-origin communication between different window objects. This method provides a way to securely circumvent restrictions on the same origin policy. So you have the message, target origin, and then the transfer. So postMessage vulnerabilities is essential to ensure that postMessage is implemented properly. If not, this could lead to security vulnerabilities such as cross-site scripting, sensitive data exposure, information theft, and others. So identifying the use of postMessage. This is something where I've had a little bit of problems because I'm like, okay, if I see postMessage, that means that could be something. Like, for example, this is a bug bounty target that I've been hunting on. And if you go here to inspect and we go to the network tab, and let's just reload. There is a main file right here, this one. And let's go to the sources from that one. Let's take that to sources panel. Now, if I go Control F and I go like .postMessage, I see stuff. Wait, this might be the wrong one, but we're still seeing stuff. See how we see s.postMessage, but that doesn't mean this is exploitable because we still need to find the add event listeners. Yeah, that's the most important thing. Is this? Here we go. Here's like message. Okay, let's just get this real quick. Here you go. So postMessage 0.add event listener. And you see how sometimes it will say stuff like, if you go back here, if it doesn't have, let's go down. This is the exploit chain. See how it's lacking the, where is it? Where it is. Doesn't utilize this right here. Do not utilize a wildcard target origin. Instead, use expected target origin with postMessage. So I see here that I'm not seeing a target origin, but it doesn't automatically mean that this is vulnerable. Like, for example, you're supposed to look for postMessages in specific scenarios. Like, for example, let's start by me fully going through this. I'm not going to bore you guys by going through all of this. I've already read this, but I will go through this real quick. And genuinely, I'm trying to get a better understanding of this. I'm probably going to do some sports figure labs and probably some other reading and actually go hunting for this in the wild. Okay, so postMessage bug hunting. Cheat sheet plus study guide. Goal, stop proving postMessages exist and start proving impact, which is exactly what I've been doing. I'll just like see it and then like, okay, does that mean it's vulnerable? I don't see the event origin or like the eval thing, but it doesn't automatically mean it's a bug. So, all right. In window.add event listener message handler, it starts with you have the attacker origin. So, okay, even this, I'm still a little bit confused about this right here. The relationship between the, okay, one second. Okay, I'm back. I was hearing something weird in my house. But anyway, so I don't quite understand the relationship between the attack origin, message handler, and sync. So before I even go further into this, I'm just gonna figure out like what's the relation. I don't understand. I'm just going to trying to look it up. So explain the relationship between attacker origin, got the I, handler, message handler, and sync/action. I think I understand sync. This is like pretty much same with like cross-site scripting, where like if you can get if you can get like a script alert, but if it's not in a spot that it's actually gonna execute, it doesn't matter. So okay, think of every post message bug as a 3-part chain: attacker origin, message handler, sync/action. If any part of the chain is missing, the bug usually dies. Okay. Attacker origin. The attacker origin is a malicious message comes from. Example, evil.com. The attacker controls a page like target window dot post message. Type update profile. Name image circ equal X. On error equal alert 1. And then I would assume this means the origin is wildcard. So any origin, I'm pretty sure. And then this means the attacker is trying to send data into the target app. Important, attacker origin is not the payload itself. It is the website/domain sending the payload. Okay. Wait, but like, I don't understand how this will get sent anywhere. Does it just send it everywhere? That just can't make sense though. I got to look into that more too. So when you test post message, the question is, can evil.com send a message that the target page accepts? If the target only accepts messages from trusted.target.com, then evil.com should be blocked. But if the handler has no origin check or has a weak check, the attacker origin becomes dangerous. Message handler. The message handler is a JavaScript code on the target page that receives the message. Example: window.add event listener message function event console.log event.origin console.log event.data. Okay, so I do know console.log is basically the equivalent of Python for print. So this handler receives event.origin, event.data, event.source, where the message came from. Event data, the data sent by the attacker. The event.source, the window/frame that sent it. A safe handler should usually do something like this. So it'll do its little thing with like the window.add event listener message function event, but then there will be an if statement. So if event.origin not equal to https trusted.target.com return handle trusted message. A dangerous handler looks like window.add event listener message function event, and then there is no if statement, and it's just document.body, and then you would have the enter.html, which I think is something else. I think that might be the sync, maybe? Is that the sync? I believe that's the sync. Yeah, handler event.data. I'm pretty sure that's the sync. No, this is the sync. Sync is right here. Isn't that also sync? Okay. Okay, yeah. So why? Because it accepts data from anywhere and uses it directly. The handler is the gatekeeper. It decides who sent this. Do I trust them? What data did they send? What am I going to do with it? Bad handlers either do not check event.origin, check event.origin weekly, do not validate event.data, trust message types/actions blindly, pass attacker data into dangerous code. Okay, sync/action. The sync or action is what the app does with the received message. This is where impact happens. Okay, so it doesn't matter. Okay, so at least to my understanding, let's say you find, for example, this, the add event listener, and it also, you have your attacker origin set up, and there is no check. But even if all of that works, like you can send the message, but if the sync to action it's not going somewhere sensitive or something, then if you have no impact, it doesn't matter. So that's what it means where it's like all three parts of the chain need to be successful for this to actually be a bug. Otherwise, it's more like just it's a gadget, it's a feature. And it might not be perfect security, but at the end of the day, nothing's being exploited. There's no impact. So why does it matter? So this is where impact happens. So sync example, DOM XSS, window.add event listener message function, and then document.element by ID output, inner.html equals event.data. If attacker sends, so this is some JavaScript, okay? Then the sync is inner.html. Oh, okay, I get it. So yeah, so inner.html, this could execute JavaScript. That can become DOM XSS. So the chain is evil.com sends HTML payload, and then target page message handler accepts it because it has the add event listener and is actually not being checked. It doesn't have the origin check, and that leads to handler puts it into inner HTML, leading to XSS. So action example account change. Not every postMessage bug is XSS. Sometimes the sync is privileged action. Example, okay, I'm going to read some JavaScript. Window.add event listener message function event. If event.data.type equal to change email, fetch /API /account /email, method post, body JSON.stringify, email, event.data.email. Okay, so if there is no proper origin check, attacker sends type change email attacker at evil.com. Then the chain is, what I don't understand is like, how does it, wait, no. It sends it because this is open and there's no check. But like, I don't understand how you create the attacker origin. How would you create the attacker origin website? So then the chain is evil.com sends change email message. Target message handler accepts it. And then handler makes authenticated request. Victim account, email change. I don't understand how this is a bug. Isn't this like self XSS? Because like, is this like a link you can send to another person? Wait, do you send like your attacker domain to the victim? Is this like a phishing thing? And then from there, they click it. They get a. I don't understand. Okay, that's also something I need to understand. Even though like I'm a bug bounty hunter, I read that it's important to. You need to think like a black hat, you could say. Not because you're actually going to do anything bad, but you just want to helps you to prove impact. So that is often better than basic alert box because it has direct account impact. The relationship in one sentence. The attacker origin sends untrusted data. The message handler decides whether to trust and process it. And the sync/action determines whether that trust mistake becomes a real vulnerability. Okay, I'm just gonna write that somewhere. Okay, I'm just gonna put it right here. Now that's important. All right, have that down. Probably gonna be it for that. Okay, so how to think while hunting. Use this checklist. Can an attacker controlled origin send a message? Does the target page have a message handler? And can the attacker controlled origin send a message? Can't that always be true? Does the target page have a message handler? Does the handler check event.origin correctly? Does event.data reach a dangerous sync or privileged action? Can this produce real security impact? The harsh truth, most postMessage findings fail at step 4 or 5. Okay, does event.data reach a dangerous sync or privileged action? Finding this, window.add event listener message handler means almost nothing by itself. So this is the handler, it's the function. Finding this, wait, I think so, right? What's the handler usually? Like I still have questions. Okay. But I'm just gonna keep reiterating this and asking the questions. So window.add event listener message function event document.body.inner.html event.data.html with no origin check is where your eyes light up. Mental model. Think of it like a delivery system. Attacker origin equals suspicious delivery driver. Message handler front desk security guard. Sync/action. What happens after the package is accepted? A save app says, I only accept packages from this exact trusted sender. A vulnerable app says the package says target.com somewhere on it, so it must be trusted. Or worse, I accept every package and I immediately open it inside the admin office. That is a bug. All right, let me go ahead and put this checklist as well. Okay. Whoops. Checklist. Write down this is a checklist. Checklist. Okay. Now I'm gonna go back here. And now I get some more questions answered. First off, what does the handler look like? Wait, no. Actually, yeah, start here. What does the handler look like in JS? Because there's just so little stuff out here on postMessage. It's really strange. postMessage handler in JS usually looks like code that listens for a message event. Okay, so the handler is going to just be like the add event listener. Be honest, like that might be kind of like, how come? Okay, whatever. It's my channel. I'll ask the dumb questions I want to. So, window.onMessage. Okay, common real world shapes. Add event listener. Handler will origin check. If origin are not equal, return. Weak origin check. For check. Handler that returns event data. Okay, handler with JSON parsing. JSON.parse. Switches message type. Yeah, so many different ways and things going on here. Okay. For the most part, I got what I wanted. So, your mental pattern. When reading JS, look for this structure. Window.add event listener message function event origin check. That's first thing we'll look for. Is there an origin check? If event.origin not equal to https trusted.com, return. 2. Data extraction. Const data equal event.data. 3. Action based on data. If data.type equal to something. And then 4. Sync/action. Your job is to answer who can send the message. What data can they send? Does this handler trust it? What dangerous thing happens after trust? Okay. And now last thing. How does attacker create, what's it called? The attacker origin. The attacker origin, which sends a post message. Do I need a domain? And I still need to have one more question. So no, you do not need a real domain to start testing. For learning and basic proof of concepts, your attacker origin can be just localhost stuff. That means your local machine is acting as the attacker controlled website. What attacker origin actually means: scheme plus host plus port. Breakdown, your local origin could be. So when your local exploit page sends a message, the target sees event.origin equal to not event.origin equal to evil.com. Basic attacker page, create a file called exploit.html. Put this inside. postMessage attacker page. Target, circ, This is the thing we're targeting, right? With page handler. Yeah, okay. And then const iframe equal document.element by ID target. iframe.onload. iframe.content.window.postMessage test. HTML, it's going to be JavaScript, URL once again. So what's the difference between this? Is this different for a reason? Then serve it locally. Open exploit.html. Now your attacker origin is your page is sending a message into the target iframe. When you do need a real domain, you need a real or deployed domain when target blocks localhost. You need HTTPS. You need to prove realistic victim attack path. You need to bypass weak origin checks like includes target.com. You need to host a page publicly for triage. For example, if vulnerable check is if includes, then yeah, you can't use that because you need it to be something where it has target.com somewhere. Or evil-target.com. So cheap options for bugman testing. Eventually get a cheap domain. loginsec, testing.com, and create subdomains like, yeah, okay. Domains do not need to be fancy, just needs attack control. You can host the exploit page, GitHub pages, Cloudflare, yada yada. Important difference: local testing versus realistic exploit. Local test, good for answering. Can I send a message? Does the handler receive it? Does event.data reach the sync? Does payload execute? Local origin. Realistic exploit, good for report evidence. Can a real attacker controlled website exploit this? Would a victim only need to visit my page? Okay, so the victim does need to visit the attacker's page. How would the victim even get to the attacker's page? Does it work on HTTPS? Can triage reproduce it? Real attacker origin. Iframe based attack. Pretty much the same thing again. Okay. Oh, okay. I get it. So, wait, no, I don't. Real attacker origin, and then iframe based attack page. Uses when the target page can be framed. So this is the vulnerable page. Yeah. What's the ID supposed to be? I guess it's just okay. And then target, yeah. And then, but why is the URL evo.com? Isn't the URL this? If the target has X frame options deny, content security policy, frame ancestors none, then iframe testing may fail. Then you have some, does not always kill the bug. You may test with pop up instead. Okay, this creates a new target window, waits a few seconds and sends the message. Then inside JavaScript handler, target sees the page is hosted at loginsec.com. Then target sees event. Ruthless part. Do not buy a domain yet just because you are learning postMessage. That is premature. Start with localhost. Then only use a real domain when you find a handler that actually has a plausible sync/action. Your workflow should be find handler, understand expected message format, test with localhost, confirm sync/action. If impact exists, Do not skip step 5. Do not skip to steps 5 before step 2. Okay, that is how beginners waste days making beautiful exploit pages for handlers that do nothing. Okay, so that leaves me with one problem, one question. How is this a bug? How is this a bug? Does victim need to go to attacker website? And if a victim went to attacker website, wouldn't that already be like bad? Yes. In most postMessage exploit scenarios, the victim needs to visit attacker controlled page or interact with the attacker controlled pop-up embedded flow. That is not automatically disqualifying. A lot of web bugs require victim interaction, like the XSS, CSRF, OAuth login, CSRF, open redirect chains, clickjacking, etc. The real question is, if the victim visits the attacker page while logged in, and the attacker caused something security impacting to happen. This could still be a bug. A postMessage bug is usually a client-side trust bug. The target page has JavaScript that says window.add event listener, accepts a message, performs action. The vulnerable version basically means I will accept infrastructure from any website. So the attacker hosts a page like evo.com, victim visits it. Attacker page opens or frames the real target. Then the attacker page sends target window.postMessage, type change email attacker at evo.com. Okay, that makes sense. So if the handler accepts that message and performs action, the victim's browser does the action while logged in. That is the bug. Okay. So the victim does not need to paste code. The victim does not need to open DevTools. The victim does not need to manually send the message. They only need to visit the malicious page, assuming the target can be framed/opened, and the handler is reachable. Example, not a bug. This is probably not reportable. Window.add event listener, message function event, console.log, event.data. Exploit chain. Attacker sends a message. Target logs it into console. Nothing security relevant happens. Okay, so then this is what you would call the sync, I guess, would be console.log. It's just, it was just going to pop up in the console like nothing bad actually happened. So example, real bug, DOM.XSS. So now it gets placed in document.body.enter HTML. Inside HTML, you can execute JavaScript. So therefore, from the attacker domain, you could input a malicious payload like AmrSec equal X on error alert document.domain. And now we have exploit chain. Victim visits attacker.com, attacker.com frames / opens target.com, attacker.com sends malicious HTML, target.com inserts it into inner HTML, JavaScript executes on target.com. This is a bug because attacker control JavaScript executes in the target origin. Okay. Impact can read page data, perform actions as a user, steal CSRF tokens if accessible, modifying account settings, interacting with same origin APIs. Example, real bug account action. Target code. Sorry if I keep sniffing, but I'm kind of sick right now. Okay, so window.add event listener message function event. If event.data.type equals update webhook, fetch, and then that method post credentials include. Credentials include body json.stringify URL event.data.url. Okay, so attacker sends target window.postMessage type update webhook URL attacker.com/webhook exploit chain. So that would go in here, right? And then the webhook would become the attackers. Okay, so victim visits attacker.com. Attacker.com opens target.com/settings. Message triggers authenticated fetch. Victim's webhook changes to attacker URL. This can be high impact if webhooks receive sensitive events, sensitive events, payment notifications, internal data, auth events, etc. When victim interaction makes it weak. Victim interaction makes the bug weaker than when the victim must click many things. The victim must already be at a very specific page. Target page cannot be framed or opened reliably. The action requires visible confirmation. Yeah, that's going to be bad. No one's going to say, yes, let me be hacked. The payload only works in the attacker's own account. Yeah, that's just like self-access, not a bug. And the impact is just alert 1 with no sensitive context. For a bug bounty, you need realistic attack path. Victim clicks one link while logged in, exploit happens. That is much stronger than victim must log in, navigate to settings, open DevTools, paste code, and then click submit. Second one is garbage. Key difference from normal CSRF, client-side request forgery. Abuses the server accepting a forged request. Postmessage abuse usually exploits the front end accepting a forged instruction, then the front end performs the action. CSRF, attacker.com sends requests directly to target.com. Postmessage bug, attacker.com sends message to target page. Target.js sends requests to target.com. The second version can bypass some CSRF protections because the request is made by the real app's JavaScript, potentially with expected headers, tokens, or request format. This is why it can matter. Your report has to prove this. A strong post-message report should show vulnerable handler code, missing/weak origin, event.origin, validation, attack controlled message, realistic victim delivery, iframe or pop-up, security impact, XSS, sensitive data leak, account change, token injection, webhook change, OAuth abuse, etc. Weak report. An attack controlled origin can send a crafted post message to settings/integrations because the handler does not validate event.origin, accepts type update webhook, and performs an authenticated request to update the victim's webhook URL. A victim only needs to visit the attacker control page while logged in. Okay, this is a strong report. That was a weak report. This page has post message and no origin check. Yeah, that you need to prove the impact, like show it. Bottom line, yes, the victim usually needs to visit the attacker website. This is still a bug only if the attacker controlled message causes real impact inside the target, origin, or victim account. The chain you need is victim visits attacker page, attacker sends post message, target handler trusts it, dangerous sync/action runs. Security impact happens. No sync action, no bug. The realistic victim path, weak bug. No impact, do not report. Okay, so now I'd say I have a better understanding of at least the theory behind it and some of the key terms like the attacker origin, the handler, source/action, sync/action. So now let me go ahead and read this. I know it's kind of a long video. Might be kind of boring to be honest, but at least this is me going through learning something new, and I think this is important for me to post on my channel because I want to see, like, look back on Logan Sack. What was he doing when he was up and coming, you know? So all right, we kind of already read this. Attacker origin, message handler, sync / action. So mental model, the 5-part chain. A report lives or dies on this chain. One weak link, keep digging. Sender. Can attacker open / iframe / pop it up? Message. Can attacker control event.data? Receiver. Which page listens? Trust check. Origin plus source plus schema validation. Sync / action. XSS, leak, redirect, or state change. So this right here. Which page listens? That's where we're gonna get the event listener. Add event listener. And then it does matter, like the trust check. And then you still need to think about, like, can we bypass? Will the message actually get sent and it will actually be inputted inside? But then we still need to think about, even if it gets put inside, is this a dangerous sync? Because if not, if there's a sync, this is a sync with no impact, it doesn't matter. So cheat sheet rule. Untrusted origin, trusted handler, dangerous sync / action, realistic victim path, real impact. Okay, so fast recon. Find listeners first. Your JS recon should flag handlers before you open burp. Yeah, I've been working on some JavaScript scripts as of late. If you want to get them, they're coming out very soon. I'd say this Friday for people who are in my list. Go to logansec.com, link in the description. And quick grep over Beautify.js. You just add some postMessage stuff. And then browser checks. Oh, yeah. Look at this. I'm going to show you this real quick. So get event listeners window.message. Be honest, I don't understand what that does. Let's go here. See, console. I click it. See, it shows something. I have no idea what this means, though. What does that stuff mean? Let's just finish reading this first. Do not stop at found postMessage. Your target is handler plus missing / bad trust check plus dangerous behavior. Okay, so you have that. You also have dev tools, event listeners, message, search sources for event.data / origin trace from listener to sync / action. Okay, but what does that mean? What does this stuff mean? Okay, I have a hard time seeing it. The window's open. But okay, what does this mean? What does this mean? Let me just make sure it gets it correctly. Let me just... Can I just... Okay, there you go. Because I genuinely have no idea what the heck I'm looking at. What does once false, passive false type message even mean? I have no clue. This means your current page has 2 JavaScript postMessage handlers registered on window.you ran get event listener window.message and Chrome return length 2. So the page is listening for incoming postMessage events in 2 separate places. What each field means. So first one, type message, use capture false. Listener F. This is actually a JavaScript function that runs when the page receives a message. This is an important part. For example, somewhere in the app, there is code like window.add event listener message event. Is there? I'm telling you, I feel like I looked. I didn't see this. Let me check. I should have everything pulled up here. If it's gonna be here, wouldn't it be in here? See, we're seeing 0. Like, what is it? We have this. Like window.add event listener test passive. I'm not really seeing, like, it's always talking about you see stuff like function event. I don't see any function event. What is it seeing? Let's test. I guess I need to, oh, what's this? Pop state. Remove event listener pop state. What's this? I don't. Okay. I'm gonna ask. Chrome is showing you that function as I need to figure out what the F function is. I need to minify this code or whatever it is so I can actually look inside it. Second one's probably minified code. Yeah. T is probably the message event. So 0 equals anonymous message handler. 1 name / minified message handler called RT. Once false. The handler does not remove itself after writing once. It will keep listening for messages. Passive false. Not very important here. Passive matters more. It's for scroll / touch events. For message events, this is usually irrelevant. Type messages confirms that the event type is post message receive event. It means the page listens for message events. Yeah. Also, not very important for post message hunting. It means the listener is not using capture phase behavior. Well, they use capture. What this does not mean? Does not mean you found a bug. It only means the page can receive. No. It can receive post messages. That's step 1. A bug requires the chain. Right now, you have only concerned message handler exists. That's not enough. You need to what you need to do next. Click the listener F or listener RT in DevTools. Chrome should jump you to the source code for that handler. You're looking for things like event.origin, event.add, event.source, or minified equivalents. Okay. Let's see. Let me go back to the console. Why is my computer so dark, bro? It's because I have to open up my window. Let's go to... Which one are you looking for? The on message one? I don't even know which one I'm looking at. Yeah, this is about to get ugly really fast. 1 second. Okay, I'll be honest, I don't know what I'm looking at. I have no idea what the heck I'm looking at. Bro, I don't know what I'm... Oh, okay. Just start opening stuff up. Yeah, I don't know what I'm looking at. Let me just look for it in here. What if I just like search for it in the source code? Sources. Actually, I wanted to ask you about this one too. What is this? Is that meaningful? For a second handler, this is probably your event objects. So inside the function, look for pretty much the same thing. What wouldn't be interesting? No origin check. I'm not seeing origin check. But like, we have syncs and stuff. It's just like, I don't know. What you should do right now in console, run this. Oh, I can run console stuff? Then run if Chrome allows it. Excuse me. It will print the actual handler code. Okay, let's see. What's this looking like? Let me just like, bro, it's not. Does the clear function work? No, okay. Let me just. Okay, so function native code. What the heck does that mean? Then run this one. Okay. Yeah, I don't know if that's important or not. I have no idea. I mean, like, it showed something. That means something, right? Okay, I'll get rid of this for now. Let me just like move this over so I don't forget about it. Goes up here. Example, just name it whatever. What the heck is that? Why is it like that? I don't know. Okay, go back. Remove. Then inspect. Does it check origin? Does it touch DOM? Your screenshot also shows download the Vue DevTools extension. So one of these handlers may be from Vue related code that often ends up being noise unless it interacts with app specific behavior. Okay. So we do have this. Let me just copy and then just paste. What does it think about this? To be honest, I have no idea. I don't know. Okay, this is almost certainly meta slash pixel IWL code, not the target app's custom business logic. What does that mean? Does that mean I'm looking at the wrong thing? Like, nah, right? I mean, it says main. It says main. It has to be for the right app, right? I mean, yeah, right. IWL likely means something like Facebook's integrated web learning, codeless events to set up behavior. This is probably loaded from tracking slash pixel scripts. Cleanup version, your minified handler. Facebook Bootstrap. What is it doing? What it is doing. Your handler receives a message event. Here. Message, origin, and extracts these fields from the message. The two accepted message types are Facebook, IWL, Bootstrap, Facebook, IWL, confirmed domain. That is your biggest clue. This is Facebook slash meta tracking tooling, not core app functionality. Is there an origin check? Yes. This part is the origin source slash validation. Var b equal dot test t dot origin t dot origin. Okay. And then d equal e. Okay. It is saying the message is trusted if t.origin matches regex, or t.origin matches regex f, or message source matches expected window slash source condition. The actual important thing now is knowing what the underscore and f are. They are probably regexes for trusted Facebook origins like facebook.com, facebook.net, meta.com. But you should not assume. You need to click around the source and find the definitions in f. Search in the same JS file for f equal, or print the file and search for, yeah, that's probably going to apply. So then scroll upward until you find f. Is this likely exploitable? Probably not. Reasons: it checks origin slash source. It only accepts Facebook specific message types. It validates pixel ID with u dash dot. Not reading that. Actions are Facebook pixel slash bootstrap actions, not target account actions. The responses are sent back to t.source, not inserted into DOM. No obvious dangerous sync like enter HTML, eval location.href. No fetch to target API or account mutation. So right now, this looks like a tracking script noise. What would make it interesting? Only keep digging if one of these is true. The origin regex is weak and accepts attack control domains. Graph token can be leaked or abused. Does something dangerous with attack control data. The message causes sensitive target site behavior, not just Facebook pixel setup. Dangerous functions here are all ones that I don't know. You need to jump to their definitions and search for them. Then check current verdict. Do not report this. Right now you found a Facebook slash message pixel post message handler with some origin slash source validation that handles Facebook IWL bootstrap messages. That is not a bug. Your next move is this. Return native code. So it is probably browser framework internal noise. This one is probably a third party pixel noise. The realist answer: this is almost certainly not where the bounty is. Move on unless you can prove the underscore or f accepts attack control origins. All right. So at least I have a better understanding of what the heck this stuff is doing and what's going on here. Still don't understand. Like, explain this to me. Let's just have it explain that to me first before I move on. Explain this. I also see this in the code. Explain that. No, I can't forget these things. Something else I found in the JS. I'm not gonna lie. I actually find JS quite interesting. Okay, this is not postMessage. This is browser history manipulation. You found code using the history API. What it means: window.history replace state. This changes the current browser history entry without reloading the page. Example: this changes the visible URL 2 seconds / profile without full page reload. Very common in React /Vue /SPA, single page application routing. This listens for browser navigation events. Usually the user clicks excuse me, is it usually this is usually just means the app is managing browser navigation. It is normal SPA behavior. When this becomes interesting, okay, now we can't trace everything. Okay, let me just get back to reading. I still haven't even read this. Like, oh my goodness, there's a lot. Okay, back into slideshow mode. Keep learning. So then we have DevTools, event listeners, message, search sources for event.data. So oftentimes, like right now, the code is minified. So we're not even going to be able to find things like event.data. It's going to be like t.data or like f.data. So a good thing to do would be like to extract the HAR files and beautify the JS and then go from there and actually take a deeper look into the code, which I plan on doing. I definitely will do it because I really do believe JavaScript is really good for a bug bounty hunter to be reading that stuff. But so do not stop at found post message. The target is handler plus missing bad trust check plus dangerous behavior. Okay, cheat sheet, source, and sync triage. This message is only interesting when it controls something dangerous. So source, event.data, parser, JSON, object, string, sync, DOM, URL, API, impact, XSS, leak, action. High value syncs, we have things like inner HTML, outer HTML. Okay, I'm not going to read all that stuff, but you can see it right here. And then low value by itself, console.log, because it's just going to like print. So even if it does print, let's say you type like script alert 1, if it's just in console, it's just going to print exactly that. It's not actually going to execute. At least, pretty sure. But if it was inside like event.data and then .inner HTML, then this is like HTML stuff, and it will execute JavaScript, at least to my understanding. That's how it would work. So post message used only for analytics, pings, strict event.origin, exact trusted origin message data, not used anywhere meaningful. Excuse me. Origin validation, good versus trash, bad. This is bad stuff. This is better. Most bypasses come from sloppy string matching. Okay, better, const allow, new, set. If allowed, has origin, return. Exact origin or properly by parsed allow list. Anything else deserves pressure testing. Okay, but the thing is, like, you can't test everything because you kind of want to. I feel like you want to skip around, not in the sense that you want to skip steps, which like first you're like, as post message possible, and then you go instead of investing like if let's say okay, so let's say post message, you learn post message is possible. Now you're trying to see like, wait, maybe you don't even want to start there. Maybe you want to start at the fifth step, which is what's the fifth step? The impact or the sync. I guess either one, either sync or impact, and I guess that's where you want to start. Because if there's no impact or no sync, there's no point trying to see if post message is even a thing. I believe because I feel like you'd just be wasting your time. I think. Okay, so. Okay, on the next one. So exploit harness, iframe plus pop-up delivery. Use simple local pages. Fancy tooling is not the bottleneck. You just have stuff like this: onload, HTML, script, then pop-up. Same thing. These are just codes for exploits. If framing is blocked, use pop-up. If pop-up is blocked, test handler behavior manually and document the limitation. And then bug class 1, DOM XSS from web messages. Cleanest bug class, also the easiest to overlay. Okay, window.event listener. Yeah, we've talked about this quite a bit. And then like output.html, there's no origin check. And then just e.data.html. Post message. It's going to be like HTML. And then you're just going to have the script. And then it's just going to send. So valid. Attacker message controls HTML/JS sync. And executes it in victim context. Weak. Alert only works on your own page or needs impossible setup. Stronger. Show account/session impact, not just an alert. But class 2, data leak through target origin. Wildcard is only bad when sensitive data can reach the wrong window. So target app, sends token, post message, attacker window. Look for data like access token, refresh token, other tokens, emails, whatever. And then proof of standard. Become the receiver. Okay, so this is kind of like a reverse, you could say. Instead of the usual attacker will send message, now it's like target app is sending tokens to attacker window. So become the receiver, capture message data, show why that data matters. Keep testing inside scope. Okay, so I could go on like how does this work? Start Googling that as well, ChatGPTing it. But like this video is already super long. It's almost 50 minutes long, like crazy. But I'll probably do this another time. Probably not even on, oh crap. Probably not make that a video, but you get the point. Where are we? Here. Okay, so bug class 3, message triggers state change. So this is where setting / count logic hunters can win. They have this stuff right here. If, webhook, update, fetch, do your thing like that. And then, oh gosh, whoops. That's not good. Move that up. Can we move that up? I think so, right? Just move that down. Okay. And high impact actions, change email, phone, add webhook. Okay, so then your best reports will not say post-message bug. They will say attacker can force a victim to change X. Okay, yeah. And then like you just make the exploit one, pretty much, I'd say. Reportability filter. This slide saves you from submitting noise. Usually reportable. DOM success from untrusted messages, sensitive tokens / user data leak, state changing action from attacker origin bypass, real sync / action, realistic victim delivery path. Usually not enough. They use post message, target, origin, wildcard with no sense of data, missing origin check, but no sync / console only behavior, requires victim to paste JS or disable browser protections. That's when we're getting into like, if you have to have them disable browser protections, that's getting into like some social engineering stuff. Okay, 1-page testing checklist. Use this before you open a report. Can attacker open iframe / opens / iframe / pop-up the receiver? Message. What exact JSON / string shape does handler expect? Trust. Is origin / source checked correctly? Validation. Is schema / type sanitized or blindly trusted? Sync. DOM sync, URL sync, API action, or data leak? Impact. What can victim lose / change / expose? Repro. Reproduce? What's repro? Can you deliver a simple exploit page? All right, so now this is going to be my 14-day study guide plan. To be honest, I move pretty quick. Probably finish this faster than that, but you know, not trying to brag, but you're bored kind of fast. All right, 3 hours per day. Oh gosh, okay, maybe not. Okay, output beats passive reading. So days 1 to 2, basics plus labs, read post message docs, complete beginner web message DOM labs. Days 3 to 5, source review, add grep mode, find 20 handlers across real JS, classify them. Days 6 to 8, exploit building, write iframe / pop-up harnesses, test origin bypasses and message shapes. Days 9 to 11, impact hunting, focus on OAuth, settings, integrations, checkout, dashboards. Days 12 to 14, reporting standard, turn best findings into full report draft, even if not submittable. Daily deliverable, 1 handler trace, 1 exploit attempt, 1 note on why it is or not exploitable. Field notes template, copy this into Notion for every handler. You can just read that. I'm not going to. Just gonna take a mental image. Okay. Ruthless standard, no saying equal no report. No victim path equal weak report. No impact, keep testing. No clear repro equal triage pain. I think it's like you don't have the exploit server set up. And so they would have to make it themselves, and that's a lot of work. All right, your first real hunting assignment. Do not start broad. Pick one app area and go deep. Pick target area, OAuth, settings, integrations, capture horror, extract, beautify JS. I have a script for that. Link in the description to logansite.com so you can sign up for that. And then find handlers, classify, 10 plus, exploit, top 3, prove or kill. Do not bounce between programs. Spend 1 full week on one target's client-side messaging surface. The win is not learning post-message. The win is building a reputable handler tracing workflow you can reuse on every bug bounty program. Okay, so we have gone through that. We did a lot of work going through, asking questions to ChatGPT. I have read this. I'm not reading this again. If you guys want to read this, it's right here. YesWeHack. Maybe it'll be linked in the description. I'm not sure if I remember. Yeah. And then also, don't forget to check out this video by AmrSec. Client side, 01 post-message bugs. Very good. I highly recommend it. So that's going to be it for this video. I just wanted to start learning post-message. And I was like, if I'm already going to be on my computer doing this, might as well record me actually learning something. Because I feel like it's been too long since I've done that. And if you like the video, like, subscribe. Also, if you want to sign up for my email list where I send the best bug bounty techniques from real write-ups I read in my own hunting sessions, maybe like in the future, when I get better at this, I'll send something about post-message bugs. Then link will be in the description. Go to Logan Sachs, add your email, and I'll send it out to you. I send out an email every week. And that's going to be it. I'm out.